So we're going to start by taking a look at the metamorphic rocks from the rocks you need to know PowerPoint. There are a few metamorphic rocks you need to know. What you need to know about them is which ones are metamorphic, and you also need to know what their parent rocks are. That's the rock that they sort of come from. So slate is is one of them. You can tell because it has like nice flat smooth lines, basal cleavage, and its parent rock is shale. Schist is a foliated rock, and its parents' rocks are shale or slate. So you can make schist a couple of different ways. Gneiss, the parent rock, is usually granite, but it can also be schist. Gneiss is sort of like the end game before things melt again. Anthracite coal, which the parent rock is bituminous coal, but it can also be peat, which is one of our sedimentary rocks. Marble is from limestone. The parent rock is limestone. And marble, you can have all different colors of marble because of all the different ways that you can make limestone. So you can have macritic limestone or encinal limestone, coquina, all those things, all of them crushed to eventually make marble. And then finally, quartzite, which looks like a messed up version of sandstone because the parent rock is sandstone. All right, so these notes are on page 93. And so let's go through metamorphic. You guys have heard the word metamorphic before. What does the word metamorphic mean? It means to change. Just like metamorphosis with like butterflies, it means to change. Okay, so metamorphic rocks are going to change. And they change from whatever their parent rock is into something else. Now, when we've talked about the other types of rocks, sedimentary and igneous, we were classifying them based on what they were made of. Metamorphic rocks are a little bit different because they're not going to be classified in that same way. Instead, metamorphic rocks are often classified using different means. So the first thing we need to know is how do we even get a metamorphic rock? And so the ways the sources, so instead of sediments or instead of lava, what you're going to have are igneous rocks, sedimentary rocks, and other metamorphic rocks can all become a metamorphic rock. Metamorphic rocks are just rocks that are made from other rocks, but not in the same way that sedimentary ones are. So what makes a metamorphic rock?
Rocks.
Right, but what are we doing to the rocks? How do we turn them metamorphic? Heat and pressure. Cool, heat and pressure. So what are the sources of heat? You can't just pop a rock in the oven and be like, cool, I made it metamorphic, right? That's not how marble works. So what kinds of sources of heat? You can bury it. You could bury a rock so deep down that it gets near to the mantle or that it gets near a magma chamber, and that will get it enough heat to change. You can also get heat from plate friction, right? It's like Mr. Miyagi. You go like this, right? And you make your hands all warm. When plates slide past each other, they create friction, which creates heat, okay? And so that most often happens at what kind of boundary? Transformed, right? Where they're sliding past each other. And the last way you can get heat is by actually contacting it with magma. So the rock runs into, or magma eats through some rock, or it goes near a hotspot, volcano, divergent boundary, something like that. Okay, so then how do we get pressure? Because it's not like you can just like sit on something and it turns into a metamorphic rock. You need a lot of pressure for this to work. So the weight of overlying rocks. Now I'm not saying like a little bit of rocks, I'm saying a lot of rocks to make this happen. Is there anyone who'd like to volunteer? You do not have to if you don't want to. Is there anyone who is okay with volunteering themselves as saying that they are in the ballpark of 167 pounds? Anybody willing to say that part out loud? All right, can you come on up here for a second? All right, so Aiden is gonna be our fabulous model of rugged 167 pounds. Okay, so I'd like you to imagine 167 pounds Aiden, and now I want you to squish him into 1 cubic foot, which is roughly the size of his head. Take all of Aiden and swoosh him into his head. That is the kind of weight and density that we're talking about. Thank you, Aiden. Okay? That's the kind of weight and density that we're talking about when we are talking about weight of overlying rocks. So it's not like, oh, I parked my car on the sandstone and it turned to quartzite. No, it's got to be really heavy stuff. Converging plates can cause pressure. We know that earthquakes are releases of pressure from when transform plates are sliding past each other. And so that pressure has to be there before then, and it can cause metamorphism in the rocks. So transform converging plates. So when two continental plates come together, the rocks fold, right? But that's a lot of pressure, having whole continents pressing against a rock. Okay, so then if that's not how we classify metamorphic rocks, how do we classify them? We classify them by where they form. We can tell where they formed by using things like index minerals. So an index mineral can tell us what temperature and what pressure a rock formed at. We know this because the A in isoda stands for arranged in a crystal structure. And the A, in this case, so that the way that it arranged in a crystal structure is because it does that at a very specific temperature and pressure. So the minerals that are in a specific rock can tell us a lot about where it formed. Okay, before anyone has a cow, you do not have to memorize all the things. In metamorphic rocks, one of the most, I think the best parts about this is that it's all about, can you read the tables that I'm giving you? Okay? So take a second and sort of absorb this table. See if you can figure out the kinds of things that it's telling you. All right, using the table, what do you think the difference is between low, intermediate, and high grade? It's low, intermediate, and high grade what?
The high grade is higher temperature.
Good. So this is the grade of metamorphism. So higher temperature, higher pressure, lower temperature, lower pressure. You can sort of tell because it says parent. Parent rock is on that side, so it's its own normal self. And then over here, it's so hot and has so much pressure it turned into magma. Okay? So, yeah, so it goes across like that. All right, so basically, as long as you can read one of these, you'll be all set. So take a look. If I told you that I have a metamorphic rock and the primary minerals that it's made of are garnet and staurolite, what metamorphic rock do I have? Schist. Okay? It's just about being able to read the table. Okay? If I said that I have gneiss, what minerals probably make it up? Sillimanite. Okay? It's just about being able to read it. Everyone feeling pretty comfortable with that? All right. So let's look at a different kind of table. When you guys are doing your research projects, I keep telling you that you have to label your axes when you make your tables, and tables like this are the reason why. Because there's no labels, or there's very few labels, and it's not very helpful. Okay? So take a look at this one. What can we see that's helpful information? What label's not on here that might help us know more?
Temperature.
All right, the temperature is labeled on the far side. It has both Celsius and Fahrenheit. Index minerals is also labeled, but what are all those other columns for? Those are parent rocks. The rocks you need to know, right? I gave you the PowerPoint, the 23 rocks you need to know. If you knew those rocks, you don't have to memorize everything about them, but you know that shale, sandstone, limestone, those are sedimentary, basalt, it's igneous. Okay, so these are not metamorphic rocks, but I know that marble and slate and schist and gneiss are all metamorphic rocks. So rocks that are in this area must be metamorphic, and these up here are probably the parent rocks. Okay, so if I told you that I have a rock that was formed at 800 degrees Fahrenheit and it's Parent rock was sandstone. What metamorphic rock do I have? Quartzite. Okay, good. What about if I told you that I had a rock that was formed at 300 degrees Celsius? Can you tell me what metamorphic rock I have? Can you tell me exactly which metamorphic rock I have? No, we're not sure yet. Okay, we're not sure yet. So, now you're going to need more information. So if I tell you that I have a metamorphic rock that was formed at 300 degrees Celsius, and the parent rock had very fine particles that you couldn't even see. Which one would that probably be? It's probably slate, because shale, we know, is made up of rocks with fine particles that you can't really see. Yes? So you just have, if you know a little bit about one of the rocks, it'll help you with the rest of them. Okay, it's all about being able to read the tables. All right, so the other way that we can classify metamorphic rocks is by their texture. There are two possible textures, foliated and unfoliated. Very, very crazy here with the scientists. They like to come up with lots of names. So foliated means bands or striped, not stripped. Look, and when I say bands, I mean that it is very obvious. So let me pass around a really beautiful tiger's eye. Sorry. A really beautiful tiger's eye, and you can see what I mean by bands. And you can see the rough side and the polished side. So this is a metamorphic rock with bands. Bands or a striped look. What does that sound like? What other thing have we already learned is going to have a striped look? I'm sorry? Sedimentary rocks have strata, right? Strata are different, okay? Strata are different than foliation. Foliation are stripes within the actual same rock. Strata are piles of rocks sitting on top of each other that are different. Okay? So it's sort of like the difference between, like, if you and your friends made a dog pile and people wearing like black shirt, white shirt, black shirt, white shirt, versus someone wearing a black and white shirt. Does that everyone understand the difference between strata and foliation? Okay, so foliation is going to happen where there's lots of pressure that smashes all those things together. Unfoliated usually happens from extreme heat, where the mineral crystals get enlarged because the rocks basically get cooked. Okay, so let's go through how we're going to be able to see these. We're going to see these because there are different kinds of metamorphism. The form of metamorphism that causes the most pressure and therefore foliation is regional. Regional metamorphism occurs where there's mountain building at collision boundaries between two continental plates. This is going to happen over a large area. I don't mean like a large area like my classroom. I mean like a large area like the state of Virginia, right? These happen over big areas like mountain range size, okay? This can also happen because of deep burial in a large area. And a great example of this are the Himalayas in India. So the texture here is foliated, and this is the sort of texture that you're going to find in most folded mountains. You can find this, like I said, the Himalayas, but in the United States, Blue Ridge and Shenandoah, the Rocky Mountains, all of those are folded mountains. They're just older folded mountains. So here are some pictures of what this would look like. And you can see for scale, here's some people. Okay? Now, what does that look like? Think way back to like January. One starts with an A, the other one starts with an S.
Anticline and syncline.
Anticline and syncline, yeah. So it looks like anticline and syncline. The difference is that when you have anticlines and synclines, and then the anticlines and synclines get crushed together, that is what makes foliation. Okay? So here's another table type for you to learn how to read. I like this one even better than the other ones. A, because it's well labeled, but also because I like pictures. So if we look at it and I said, all right, I've got sandstone. Sandstone bends pretty easily. It's going to make a nice anticline at first. But if you put enough pressure on it, what will sandstone turn into? Quartzite. Good. Okay. So if I told you that I have marble, what would be the parent rock for marble? Use the table. What's the parent rock for marble? Limestone. Right? You just find where marble is and you follow it back. You can see that even marble, which is a metamorphic rock, can be metamorphized more, okay, into deeper marble. A lot of metamorphic rocks end up as gneiss. What happens if you metamorphize gneiss? It becomes magma or lava, okay, usually magma. All right, so what is going to be easier to metamorphize? Something like pumice or something like granite? Think about it. Which one's going to be easier to change up? Pumice or granite? All right, I hear people saying both. Okay, if you think granite would be the easier one to change up, why? There's no holes in it, so it would be easier to change. Okay? Tyler, you have a different idea?
Oh,
Or same idea, you're for granite?
No, for pumice.
You're for pumice, okay? Why pumice?
It's less dense.
Because it's less dense. Yeah, the less dense something has, the more holes it has in it, the easier it is to go. I'm not going to do this because rocks are expensive. But I can literally, if I was being crazy, I could literally just go like this. If I put enough pressure on it, I can crush pumice in my hands. That's not the kind of, if you put like metamorphic size pressure on something, this is definitely going to go, right? It's going to be easy to go. And you can tell because some of these change many times. So siltstone will become slate, which will become phyllite, which will become schist, which will become gneiss. It's very easy to metamorphize. You don't need a lot to move it to the next stage of the game, okay? Whereas marble takes a pretty long time staying marble, and even then, it's mostly going to melt by itself without necessarily becoming gneiss. Does everybody understand sort of what we're doing here? Okay. So here's a different way of looking at the same chart. When you can look at the transition of slate as it goes all the way over to a partially melted stuff, because it has increasing foliation, increasing temperature, or metamorphic grade as it goes. Everybody good on this? Okay. So then the next type, that was regional metamorphism, takes place over a large area. Dynamic metamorphism is different because it is going to be uniquely positioned to only happen at transform boundaries between moving plates. So as plates slide past each other, they are going to release a lot of pressure and create friction, which creates heat. The heat and the pressure from that can create metamorphic rocks. Now I only have one slide on this because there's not a lot of places where this is going to happen, and it happens very quickly, okay, as the plates are sliding past each other relative to other types of metamorphic rocks. So in the United States, you can find this along the San Andreas Fault in California. And this is going to be very localized, so specific to a place, whereas regional, like we said, was over a big area. In terms of texture, because this can cause heat or pressure, you can just put an X in that box, because it's going to have all different kinds of textures. It could have all different options, right? Because there could be metamorphic rock already there that gets metamorphized a second time with the second move of the plates. All right. So the third type of metamorphism is contact metamorphism. Contact metamorphism is when there's extreme heat because it comes in contact with magma or some other hot fluid. So, for example, if you have a geyser or a hot spring or igneous intrusion or magma chambers. And when I say igneous intrusion, what that means is that there was some magma and it tried to push through the rock to get to the top, but it didn't get there. It sort of eats these rocks along the way. But the parts of the rocks that it doesn't eat It's so hot that it basically cooks these other rocks and turns them into a new metamorphic rock. So limestone becomes marble, and mudstone or siltstone becomes hornfels, sandstone becomes quartzite. But then this, as it freezes and cools, will become an igneous rock. So you can have an igneous rock next to a metamorphic rock, next to a sedimentary rock, all in one place. So contact metamorphism, while it creates unfoliated metamorphic rocks, can be a really interesting one because you are, it's going to be specific to a place where there's lava. Divergent plate boundaries, hotspots near a volcano. To see what this might look like, I'll pass around an example in a second. Okay, so what is metamorphism going to do to a rock? All right, metamorphism is going to first destroy all the holes and all the fossils. It's going to eat those right up. It's going to crush them, turn them into fine powders. The compression stress takes away any pore space. So when that happens, the rock density increases. Just like if we tried to squish Aiden all into his head would get much heavier, right? Let's not do that, by the way. We like Aiden just the way that he is. Don't have to squish him. Okay, so that's two. The third thing that can happen is that mineral grains are flattened and then enlarged and elongated. The way I like to remember this is sort of like making a peanut butter and jelly sandwich. You have the bread on the bottom, and then you put your peanut butter on, and then you put your jelly on, and then you put more bread on the top, right? Okay, so if you squish your sandwich down to like put it in the wrapper, and you used actual jelly, and there's excess, it sort of squishes out the edges, right? Okay, so it stretches and elongates. But what happens if you use jam instead of jelly? And you have like chunks of fruit, like I like strawberry jam in my sandwiches. So what happens when you have like a chunk of strawberry there? Does that part squeeze out usually? What does it do when you sort of squish your sandwich? It like pushes up through the bread, right? So that is something that can happen here. Okay, so it flattens as much of the grains as it can, but when it can't, it'll stretch them out and sort of smoosh them in different directions. A lot like a peanut butter and jelly sandwich. All right. Any questions about what metamorphism can do to a rock? Are you laughing at me saying smoosh? No? Of peanut butter and jelly sandwiches? I made a triple decker peanut butter and jelly sandwich today for lunch. It was so delicious. Little pretzel buns. Okay, sorry. Common metamorphic rocks. This is the last part that you guys need to know. So these are the ones you really, really have to know who the parents are for these rocks. Shale becomes slate. Granite gets gneiss. Sandstone makes quartzite. This one makes sense because sand is mostly made of stuff that's quartz. Limestone makes marble, and peat or bituminous coal makes anthracite coal. Are there any questions about metamorphic rocks?